Okay, so rational word problems. So we're still dealing with fractions. Okay, that can have variables in the denominator or on top. I'm sorry, I was looking at the practice. I was like, why y'all were confused? My bad. Here, JK, notes. Okay, but anyways, still looking at rational things. We're still looking at word problems. Now, a lot of what we're going to do today is going to be cross-multiplying versus common denominator. A little bit of what we're going to do today is common denominator, but a lot of it's already set up for cross-multiplying, so it's just easier to cross-multiply, yes? Okay, and we're going to think smarter, not harder. Do y'all remember doing proportions? I think y'all did them in junior high, maybe even elementary. I don't know, y'all. But I know y'all have done them. Maybe even a little bit in geometry. Proportions just mean that, like, a lot of times I feel like I remember proportions more so with shapes. Like, if these shapes are proportional, then you can use this to find the missing piece. No? Does it at least look familiar? Okay, cool. But I'm going to show you what that means here in a second. So, solving proportions. See how this is set up for cross multiplication? Yeah, you can literally just do 5 times x is 5x. 45 times 7 is 315. And remember, the equal sign stays in the middle. Everybody okay with that? Now what do I do to solve that? Divide by 5. And I get x equals 63. Now I'm going to show you that these are proportional and what proportional kind of means. It'll make more sense. Proportional is always with fractions. I guess they could be whole numbers that you make into fractions. But if I do 45 over 63, what does it equal? 5 over 7. However, it could also equal 10 over 14. Like 10 over 14 is also proportional because 10 over 14 simplifies also to 5 over 7. Pretty much anything that can simplify to 5 over 7 is proportional. Yes? Okay, so that's all that means. So like 2 over 4 and 4 over 8. Are those proportional? Yeah. Yes, because they both equal what? 1/2. So those are proportional. Yes? Does that make sense? Anything that simplifies and equals the same thing is proportional. Cool? Okay. So looking at this one, obviously this one's not as like pretty to simplify, but it's still simple to solve. I'm going to draw my arrows down, bless you. I have 3 times x plus 2. Bring down my equal sign. And then 5 times x minus 5. Bless you. One thing I do want to say, I saw this a couple times with people cross multiplying. Make sure you're drawing your arrows and going diagonal. I had a couple people trying to multiply what was on the bottom. You don't go down, you go diagonal. Yes? Cross multiply. So 3 times x is 3x. 3 times 2, 6. And that's fully simplified, so we're good. 5 times x is 5x. 5 times negative 5 is negative 25. Now, how do I solve that? Negative 3x. I'm going to minus 3x on both sides. I always like to move my smallest x because then I don't have to deal with negatives. And that gives me 6 equals 2x minus 25. Now what? Plus 25 on both sides. I'm going to bring it up here. What's 6 plus 25? 31. And last step. Not negative 2. These are multiplying, not adding. So we're going to divide by 2. Remember, we're doing opposite operations. So these 2's cancel, and I get x equals, well, 31 over 2 is fully simplified. And if you ever aren't sure, y'all, you can do alpha y equals enter 31 over 2. Did it equal 31 over 2? See how it didn't simplify? It's because 31 over 2 is fully simplified. If you want to write it as a decimal, as long as you're not rounding, I'm okay with a decimal, yes? So you could write 15.5. Now, on word problems, will you round? Yeah, because if I ask you how many hours and you tell me 31 over 2, does that make sense? Like if somebody answered your question like that, would you look at them like they're crazy? Okay, answer realistically, yes. But in problems without words, you can leave it as a fraction or a decimal as long as you're not rounding. Yes? Cool. Any questions with those? Okay, if you look at number 3 and number 4, they're actually exactly the same, except you have to set them up. Okay, so number 3 says, many people still rent movies and video games with Redbox. Do y'all still use Redbox? Okay, I didn't think people did, but I didn't want to judge nobody. If renting 3 movies costs $4.50, it's also not that cheap. How much would 5 movies cost? As long as you set up the fractions the same, it'll be equal. The only time people make mistakes here is when they accidentally flip-flop them. So I'm going to do movies over cost. So the first rental was 3 movies for the cost of $4.50. That's my first fraction. And that should be equal to 5 movies for how much money? X. Yeah, we don't know. So we're going to put an X. So now we cross multiply. So 5 times 450 is 22.5 equals 3 times X, which is just 3X. And what's my last step? Divide by 3. And what do I get? 7.5. Now, 7.5 stands for what? The cost. Yeah, it's the cost of 5 movies. So how do I write cost? Because it's not like that. $7.50. You're going to write it as this. Remember, word problems get word answers. These aren't technically words, but it's labeled correctly. Does that make sense? Okay, don't forget to label your word problem answers. Any questions so far? Okay, so same concept with the shapes. If these are proportional, no matter how I set them up, as long as I set them up the same, it's going to give me the same answer. So I'm going to do the short side over the long side. So 2 over 10 for my smaller triangle. If these are proportional shapes, should be equal to 3 over my unknown side. Yes? And then we cross multiply. 3 times 10 is 30 equals 2 times x is 2x. What do you do? By 2, and you get x equals what? 15, and this is a word problem, so what's my answer? 15 yards. Any questions with proportions? Super simple, we like those. Yeah? Okay. So now let's look at work rates. These are a little weird to set up, but once you get them, they're pretty simple. Yes? They're not as bad as the last time we were setting up tables, I swear. Okay? So Sam, I'm not going to worry about last names. Also, please forgive me with my typing. I will point out my own mistakes here in a second. Sam and Frank work in a plant that manufactures automobiles. Sam, not same, can complete a quality control tour of a plant, not a plane, in 3 hours. So Sam, total time, can do his in 3 hours. Frank, however, needs 7 hours to complete the exact same job. Frank needs a new job. I'm just kidding. But that would drive me crazy if I was Sam. The regional manager is coming to inspect the plant, so both Sam and Frank are directed to complete the quality control together. Well, we don't know how long it takes them to complete it together. That's our unknown. How long will it take? Well, that's what we're trying to find. That's why we put x, because that's what our unknown. Yes? Everybody okay with that so far? So, as weird as it sounds, we have no idea how long it's going to take them to complete together. But we can figure out how long it's going to take them to complete in 1 hour. Because, so in 1 hour, what's the, or not the percent, but the fraction of the way done that Sam's going to be? If it takes him 3 hours, what's the fraction complete he'll be in 1 hour? 1 what? 1/3. He's going to be 1/3 of the way done in 1 hour. Yes? How close to done will Frank be? 1/7. And together, well, we don't know, so it's just 1/x. Sounds really weird, but it works. You don't have to draw the lines. I'm just trying to make it more, whoop. Don't be like me and draw lines for your numbers. Okay, well, what I want you to know is that this plus this equals that guy. Because together, in an hour, they're going to be this far complete. Yes? So 1/3 plus 1/7 equals 1/x. Well, do we know how to solve that? And x represents their total time. So in the end, will we find the final time that will complete the whole job? Yes. So how would I solve this? What do I need to do? So this is one we're not going to cross multiply. Why not? Yeah, we need a common denominator, but it's because you don't have one fraction equals one fraction. Y'all, cross multiplying is for when you have a single fraction equals a single fraction. Is this side a single fraction? No, it's 2. So you can't just cross multiply on this one, okay? That's why we have to find our LCD, our least common denominator. So what is our LCD here? Huh? Well, if you don't know, can you just multiply the 3 of them together? What's 3 times 7 times x? 21x. Even if that's not your least common denominator, guess what? It's still going to work. However, that is your least common denominator here. Okay? So knowing that, 3 times what gives you 21x?
7.
Times 7 what?
X.
So we're going to multiply 7x on top and bottom. 7 times what gives you 21x?
3x.
And then 21 times x is 21x. Will all my denominators equal 21x here? So can we cross them out? Yes. 1 times 7x is 7x plus 1 times 3x is 3x equals 1 times 21 is 21. My denominators matched, so I got to cross them out. Now what do I do? Yeah, I can solve. Is there anything squared? No. So do I have to factor? No. So we like this one. What's 7x plus 3x? 10x. And I need to get x by itself, so what do I do now? Divide by 10. And what does that give me? What?
21/10.
Simplify. Because does that make sense? Like if somebody asks how long and you tell them 21/10, is that going to be an answer that you want? No. It's dang it. I meant to divide. 2.1. Okay. So it's 2.1. However, I'm okay if you write 2.1 hours. But what if you had multiple choice and it was saying hours and minutes? How would you find out what that would be? So it's not 10 minutes. Because remember, minutes, there's only 60 minutes, not 100.
30 minutes.
So watch. No, that'd be a half. Remember, half an hour is 30 minutes. So if you ever don't know the minutes, you're going to take your decimal only, so 0.1, and how many minutes are in an hour? So times 60, and how many minutes? 6 minutes. So it's 2 hours and 6 minutes.
So wouldn't it be 60 divided by 10?
No, because it's not 10, it's 0.1. So 0.1, and there's not, think about it, decimals go up to 100, right? Or 0.99, or even more actually. But like minutes is only 60. And decimals don't only go to 60. So that's why you have to multiply your decimal times 60. Does that make sense? Any questions at this side? Okay, so let's try one more like that one. Okay, now we have Cindy and Mary. They own a landscaping company. Okay, and Cindy can complete a certain garden planting in 3 hours, while Mary takes 4 hours to complete the same job. If both of them work together, how long will it take? So same concept, different numbers, yes? So we have Cindy and Mary. I'm not going to write full things. We have the total, and we have 1 hour. And then we have together. Don't forget together. So how long does it take Cindy? 3 hours total. How long does it take Mary total? 4 hours. And how long does it take them together? We don't know. So now in 1 hour, we know that Cindy will be 1/3 of the way done. Mary will be about 1/4 of the way done. And together will be 1/x of the way done. So together is plus, and then equals are together. So 1/3 plus 1/4 equals 1/x. What is your LCD going to be? 12 what? X. So 3 times what gives you 12x?
4.
Times 4x. So 4 times 3x. And then x times 12. And now all of our denominators, 3 times 4x is 12x, 4 times 3x is 12x, x times 12 is 12x. They match, so we cancel. 1 times 4x is 4x, plus 1 times 3x is 3x, equals 1 times 12 is 12. What's 4x plus 3x? 7x. What do I do now? By. And what does that equal? It's not pretty. 12 divided by 7. It gives me this. So I'm going to have to round. Okay? It doesn't specify what to round to, so you can round to whatever you want. I like to round to the tens place if it doesn't specify. So it's just, what would that be? 1.7. So it was telling me how long will it take them to plant the garden together. That's x, so it'll be equivalent, or approximately, 1.7 what? Hours. Now, if you don't put this squiggly equal sign, do y'all know what that means? It means approximately. So when you round, that's what that means. Approximately 1.7 hours. If you don't put that, I'm not going to take off. But I want you to get used to seeing it, because you will see it if y'all go to college and take math. Or go take it further math. Any questions with number 6? Okay, one more type of problem. Last type, I promise. This is distance. It's very similar, but a little simpler, I think. Okay, so a car travel, well, first, distance equals rate times time. We know that, yes? That's going to be given to you. Distance equals rate times time. Don't have to memorize. Well, just like literal equations that we did yesterday, what if I wanted to solve that for t? What would you do? Divide both sides by what? By the rate, by r. So divide by r, and then you get time equals distance over rate, right? So we know that distance equals rate times time, and time equals distance over rate. Those are both equal, and they both work, okay? You need to know that for this problem. It's going to help you. Yes? Okay, so knowing that, it says a car travels 180 miles, and the same time a truck travels 120 miles. So the car's distance is 180, and the truck's distance is 120. And both of those are in miles, so we're good because they're the same measurement. And it says in the same time. We don't know what the time is, but we know they're equal. So I'm going to put this little equal sign between the two time boxes just to remind me that I know those are equal. Yes? Okay, if the car's speed is 20 miles per hour faster than the truck's, find the car and truck's speed. Well, did I know the truck's speed? What do we use to represent what we don't know? X. So we don't know the truck's rate, the speed. But what do we know about the car's speed? How do I represent that? X plus 20. What if it said slower? It'd be X minus 20. You're exactly right. But it said faster, so we're good. Everybody okay with this? Okay, but we don't know what the time is. And we need the time to solve it because we know times are equal. Okay? And that's how we're going to solve this because that's how you'd set up an equation. So knowing that, we know time equals distance over rate. Well, we know the distance, we know the rate, so we can find what represents time. Yes? So knowing that, distance over rate, 120 over x, and then distance over rate, 180 over x plus 20. And we know those are equal. So 120 over x equals 180 over x plus 20. Do I know how to solve that? Yes. How am I going to solve it? What's the easiest way? Cross multiply. So I'm going to cross multiply. 180 times x is 180x. 120 times x plus 20. Well, I'm going to write it out because I'm going to have to distribute that. And I don't want to make any mistakes. So this left side doesn't change. And I'm going to distribute. 120 times x is 120x plus, what's 120 times 20? 2400. 2400. Now what? Subtract 120x because there's nothing squared, so we don't have to factor. We just got to get all of our x's on one side. So minus 120x on both sides. And that gives me 60x equals 2400. Now what? Divide both sides by 60. And what does that equal? 40? Yes. Now, go back and read your question. We have to figure out what it's asking us. It says find the car's speed and the truck's speed. Well, what does x represent? The truck speed. So how fast was the truck going? 40 miles per hour. MPH represents the way you label that. I don't know what I was trying to say. And how fast would the car be going if it's 20 miles per hour faster? 60 miles per hour. So always make sure you go back and read what it's asking. Because sometimes it wants more than just what x equals. Yes? Because what if it just asked what was the car's speed and you put 40 miles per hour? Is that right? No. So be careful. Yes? Yes. Because we knew that x is 40 and the car's rate was x plus 20. So 40 plus 20. Any questions on that one? Okay, one more very, very similar just to go over it one more time. So this time we have a bus and a car. And we have distance equals rate times time. So I know that the bus travels 180 miles for distance at the same time. So again, times are equal. That the car travels 240 miles. If the car's speed is 15 miles per hour faster than the speed of the bus, find the speed of the bus and the car. Do we know the bus's speed? So what do we use to represent that? And what represents the car's speed? Perfect. Dang it. My pen died. Okay, and we don't know time, but we know it's the same. What are we going to do to represent time for the bus? 180 over x And what are we going to use for the car? Perfect. And we know they're equal. And we're going to cross multiply. So I just want y'all to keep working that out. That's 2,700, right? 180 times 15? Yes. Because we're going to distribute that. When you're finished, I want you to check the board and see if you got it right. Okay, any questions? Are these as bad as the other word problems? No. Okay. Are they still tedious? Yes. But they're not as bad. Okay, so this is what you're working on. If you have questions, what should you do?